Now we come to the point that is normal distribution. Normal distribution, this is continuous probability distribution. The statistical data relating to business and economic problems. Social and physical science are displayed in form of normal distribution. You can see the lifetime of television tube and height of the people, marks of the students in a large class, weight of packages produced by a machine are approximately normal distribution. So that is why in your A level, advanced level university admission, so they use normal distribution function. That's why you get a set score. Based on this principle, they apply set score. You see the lifetime of the television tubes. Say here, lifetime a TV tube. So TV tube mean you may you might see the TV. Now we can see the LCD or LED TVs. Earlier, we got a tube. So the TV like this. So this is what inside you can see a TV tube. Here's a lifetime. Say one tube may have the lifetime 10,000 hours. Average on average, it may have 10,000 hours. It may work lifetime. And the height of the students, height normally on average height of the student, height of the any humans 6 feet. In Sri Lanka we may have 5.10 or 5.8, and the marks of the students in the large. So here students get marks in a particular exam. They may get 0 to 100. On average they may have 70 or 60. Most of them are getting average marks. And weight of the package produced by a machine. All these are follow normal distribution. Say, assume that the exam score in a subject, say mathematics subject, when we plot this in a histogram, it's like this. So this is average marks. Say we can say 70 marks. This is average. Most of the students will get this marks. Mode, like mode, median, and mean, median, mode. Right? Mean, median, mode. Most of the students get these marks. And some of the students, right? Some of the students get higher marks than the mean. So X is here. It goes up to 100 maximum, and also here was the 0 minimum. And this is the middle point. So this is normally distributed. Some students get 70, some of them are getting 70.5, some of them are 78.2. So it takes any value within the range. Right? The student marks get any value within this range. Any values, infinite number of values. That's why we call them as continuous. Not like 1, 2, 3. When we throw a dice, 6-face dice, it has a definitive value 1, 2, 3, 4, 5, 6. When we throw a coin, we get head or tail. A number of students, it has definitive number 20 students, 40 students, right? When we count mangoes, 1, 2, 3, like that. When you find the head 1, 2, 3, 4, it has unique numbers. And the shoe size, right? Shoe size, say 6, 7, 8. Sometimes it may have 6.5, 7.5, but it has its specific value. But you see the marks, weight, height, lifetime of the TV tube. So those are having, right, infinitive number of infinitive values. Say the marks. Average marks we can say 70, minimum 0, maximum 100. Within this range, it take any value. Say some students may get 20 marks, some students may get 2.22, someone may get 22.00232 like that. So it takes any inferior numbers. That's why we consider them as a continuous variable. Continuous variable. For continuous variable, normally we may apply normal distribution. So these values, when we take the large observations, it are approximately normally distributed. Let's move the slide. The Manager's Blueprint, Decoding Business Probability, a practical guide to mastering normal distribution for business decision making and exam success. You see, the natural shape of business data. You see the lifetime of the TV tube and the height of the students, and you see the weight of some packages. Whether you are tracking the lifespan of the TV tubes, employee metrics, and machine package weights, business data reliably forms a symmetrical bell curve. Symmetric, I have already explained, right? Symmetric, right side and left side should be equal, and mean, median, and mode will take the same value. This predictably is your ultimate management tool. So here some of the properties of normal curve. The peak, this value, this is x, this is x bar, this is the mean, right? So this top, the peak, mean, median, and mode all share the exact same value, right? The center, this is the mean, awesome, right? Mean. Another property, perfect symmetry. Perfect symmetry means the right side is perfect mirror image of the right side. So this shape is exactly same as an infinite tail. In the end of the ends, right here is the end, this is the curve. So this is called tail. This portion is called what? Tail. This is tail. The end gets closer and closer to the x-axis but never touch. You see this tail goes infinitively, right? Infinitively, but this tail will never touch this x-axis. So always there's a gap. Never touch right side or left side. This tail never touch x-axis. But it's bring, right? It's come closer but never touch. The ultimate rule is the total area under the curve, right? The total area under the curve exactly equal to 1, right? Or 100%. That's the rule. Ultimate rule is what? The total area underneath this curve always exactly equal to 1. Exactly 1. So that's the principle we have to remember always. The golden rule to find the area, we know that how to find the area under the curve using integration function. We already proved that area under any curve, area under the curve equal to probability area. So the total area under any curve is equal to 1. That's rule number 1. And if you want to find the probability between A and B, x value A, x B, this is upper limit, this is lower limit. The area under the curve, or to find out the probability between these two values, this is A, B, C, D, right? This is the area under this curve, A and B. So if you want to find the probability A and B, so the area A, B, C, D is the probability. To find the probability of a business event happening within a specific range, so this is the range. This is the range. We don't count individual data points. Instead, we calculate area under the curve between those 2 points. So we don't want to find the each and every point. Simply, if we find the area between the range, that's equal to probability. Right. Now let's see probability density function, PDF, probability density function of a normal distribution. In the normal distribution, mathematical function that describe the probability density function of random variable x is called probability density function. This function shows the shape of the curve and how data are spread around the mean. It is given by the formula. Right? This is the probability density function. And here we can see the pi and e, right? We have things. This is the probability density function of the normal distribution. It's look very complex. In the normal distribution, fx is not the probability. Here, this is density function, not the probability. It's a probability density. Probability is calculated the area under the curve. Remember, this is function. This is probability density function. To find the probability, we have to find out the area under the curve. Probability is calculated as area under the curve. The normal distribution fx is not the probability. It's a probability density function. Keep in mind. And the good news is the probability function, right? And why you can ignore it. You don't want to remember. You don't want to remember this function, right? So you do not memorize this function because here statisticians already did this terrifying mathematics for us. They created standardized table. For your exam, you will never calculate this equation. You will simply look up the answers in your table, but use the table. But to use the table, you need a translator. You should know what's the logic behind the table. Right. Here, as we discussed, the TV tube lifespan, say the mean, say for example, 5,000 hours. Standard deviation 200 hours. So it's look like this. Behavior look like this. Employee salary, mean 60,000 and standard deviation 5,000. And package weight, mean 50 kilograms, standard deviation 2 kilograms. You see the distribution shape, the bell shape looks identical, looks same, right? The distribution looks same, but we can see it has different mean values. So here, so this is the distribution of TV tube life now. So this is value of x. This is the average. This point is the average, x bar. Average. Here the what's x bar? 5,000. So this is standard deviation. And here for this distribution, so this is the mean 60,000. Here 5,000 x value, and here x value is x bar is 60,000, and here x bar is just 50. Right? The shape are identical, almost identical, but it has a different value of x. Every unique business problem has its own mean and its own standard deviation. We cannot carry thousands of different probability tables into the exam. So we need to convert them all into one universal language. Standardize. We have to standardize. Here we have 5,000, we have 60,000, we have 50, right? We have different x values and different standard deviation. So as I told you earlier, the statistician already they have created table, standardized table. So To use the standardized table, we have to convert these different business scenarios into standardized form. That's called in standardization. Normally, we call them as Z. Z means standard. That's why in your A-level exam, you get set score. Right? Set score. Here, standardization. The standardization of normal distribution. In a normal distribution, we call mean as the mean, and standard deviation equals sigma. So we write this: x approaches normal distribution, x random variable x approaches normal distribution, mean and standard deviation. Sorry, mean variance, mean comma variance, not standard deviations. Here we have scalar. So this is variance. X random variable x approaches normal distribution with mean mu and variance sigma square. The normal curve of on x scale, you see the normal curve is bell shaped and symmetrical about the mean. The key point on x axis are, you see the middle, you can see the mean average, and the left right side you can see mean plus 1 standard deviation, and here mean minus 1 standard deviation, mean 2 standard deviation plus, and mean minus 2 standard deviation, mean plus 3 standard deviation, and here left side mean minus 3 standard deviation. It continues forever because the shape is like this. This is mean, this standard deviations. Here, so this is the mean, the top we can mean, median, mode. And now when we standardize, we have to make the mean 0, right? So I'll explain in detail here. Why standardization necessary? Here, I'll explain this. The most values lies close to mean. So here when we see the normal distribution, so this is the mean, this is the mean. Most of the values, you see, these are the histograms. There are thousands of histogram, thousands of columns within this. When you look at this, the data points, most of the values close to the mean, and sigma measures the spread. So sigma means standard deviation. If it is low standard deviations, look like this. If it is high standard deviation, the bell shapes like this. So white. Why is standardization necessary? Why do we need standardization? Each normal distribution may have a different mean, and it has its own standard deviation. So they have different mean and they have different standard deviation. So therefore, constructing a separate probability table for every distribution would be impractical. Consequently, it is necessary to transform all normal distribution into single common form, right? So here the TV tubes and employee salary, student marks, package weight, they have their own mean and standard deviation, but all of them are follow normal distribution. Now we try to standardize. Standardize mean we convert the mean average value equal to 0. That is standard deviation, standardization. Here the z value, the z variable, standard normal variable. Here already we have x. Now we have to convert into what? The x is the variable. We have to convert into z. Z means standardized number. The transformation formula used to convert any normal distribution into common standard form. This is the formula. So z means standardized value of x. Here x minus mean average divided by standard deviation. Very simple formula. We have to remember this formula. This is the foundation, right? By using this formula, you can convert any x values to z value. Say for example, here TV tube 5000 hours, no, 5000 hours, and now this 5000 mean, no, this is mean becomes 0. So and the employee salary is 60,000, right? When we standardize, this mean becomes 0, and the package weight, say 50 kilograms, becomes 0 when we standardize. This transformation is called standardization. When we standardize, the new distribution obtained through the above transformation is the standard normal distribution. Earlier, we looked like this. Here, x approaches normal distribution with mean variance. Now, we convert this x into z. The z approaches normal distribution with mean equals 0, standard deviation, so variance 1. Here, actually, not variance, yeah, variance and standard deviation 1, right? It's normally we in the standard distribution, we call them what, standard deviation, not variance. On this curve, z scale point here 0 represent mean, and here this mean plus 1 standard deviation. This is mean plus 2 standard deviation. This mean plus 3 standard deviation. Likewise, here this one mean minus 1 standard deviation. This is mean minus 2 standard deviation, like that. So when we depict in the graph, it's like this whole curve centered at mean. Right now we convert the mean value into 0. This is z, right? This is z. Here earlier it was x values, x. Now it's become z. Any mean value, right? Any mean value of x become z equals 0, right? Set 0. Mean value becomes 0. You see, when you look at here, most of the values, this height, no, height, density, probability density, most of the values are lies here, right, in the middle. Most of the values. This is standardized, standard normal curve. Here, in the standard normal curve, mean equals 0 and standard deviation equal 1. X-axis is converted to z values, z scores. X-axis is converted to z scores. The z score, what do you mean by that? Z score, a number of standard deviation, here sigma, a value is form of the mean, value from the mean. Here you see, understanding the transformation through normal curve. When the x value equal to mean, right? A particular value x equal to mean, that instant z equal 0. When x here mean plus 1 standard deviation, then we call them as z equal 1. When x, right, x minus 1 standard deviation, right, x minus 1 standard deviation, then it's become minus 1. And here x plus 2 standard deviation, now it's become z equal 2. You can observe here, mean plus 1 standard deviation equal 1, mean plus 2 standard deviation equal z equal 2, mean equal 3 standard deviation, z equal 3. Likewise, here mean 2 standard deviation, mean minus 2 standard deviation equal minus 2. Likewise, mean mean minus 3 standard deviation equal z minus 3, right? So this is the logic behind this. I hope you understand everything. If you have, we can ask. Since we have lectures at 8:30, so I stop the session now, and we will continue at 1:30.